we want to find the integral of the ln of x cubed divided by x dx. In this problem, notice that we've got something that we cannot simplify to be one of our basic antiderivatives. Also notice that this is an indefinite integral and it is just asking us what is the antiderivative function. What is the most general antiderivative function? So when you see that, you should have a plus c in your answer. In this problem, you notice that this is a composite function. There's an inside function to this. So usually what we do is we try u substitution and we let u equal the inside function, and hopefully that makes our problem look a little bit easier. So if u is equal to ln of u, then the differential du is the derivative of the ln of x, 1 over x, times dx. So when we do this, we're taking the derivative of the ln of x there. Then we're going to look and see, can we write that in this form and change variables from x's to u's. So I'm going to rewrite this real quick, and I'm going to write it as the ln of x cubed times 1 over x dx. That's an equivalent form of what I started with. Now notice that since we've got the ln of x there, we called that u, and then we found du by taking the derivative. There's our du as well. So this is a pretty straightforward u substitution problem, and this gives us the integral of u to the third du. Now, what is the integral of u to the third du? It is u to the fourth divided by 4 plus c. So that's just the power rule. The question we started with was in terms of x's, so our answer should be in terms of x's. So this is the ln of x to the fourth over 4 plus c. Our next problem, back up. You can check your work by taking the derivative, and hopefully after doing your chain rule, you will get what you started with. For part B, notice we have a definite integral, so our answer should be a number. This is also a u substitution problem. Notice we've got an inside function here. So we're going to say, let's let u equal 1 plus 5x. So du equals 5 dx. Now I see dx in my problem, but I don't see 5. So what I'm going to do when I rewrite this again, I'm going to divide by 1/5 and multiply by 5 so that I have the cube root of 1 plus 5x, close that cube root, 5 dx. So now when I look at it, I've got my u there, and I've got my du there. So now we're going to make the substitution from x's to u's. My 1/5 carries down to the next step. That's just a constant multiple. We can keep that factored out. So when I did that, multiplying by 5 and dividing by 5 is multiplying by a form of 1 to avoid changing the problem. So now I've got the cube root of u. But the cube root of u is u to the 1/3 power. 5 dx is du. But notice this is limits of integration. This is x equals 0 and x equals 1. I don't want x's in my problem. I want u's. So what is the u that goes with x equals 0? So what we do is we substitute x equals 0 back into our equation that we used for u, and we have 1 plus 5 times 0 is 1. So now this is a value for u. Then when I let x equal 1, 1 plus 5 times 1 is 6. So my new limits of integration are now 1 and 6, and those are in terms of u instead of in terms of x. This allows us to take the antiderivative and evaluate using the fundamental theorem of calculus part 2 without having to go back to x's. So it saves us 1 or 2 steps of back substitution. So we've got 1/5. Now I'm doing my power rule for antiderivatives. U to the 1/3 plus 1 is 4/3. Divided by 4/3 is times 3/4. And then evaluate it at 1 and 6. So what we have is, looks like 3/20 times 6 to the 4/3 power minus 3/20 times 1 to the 4/3 power. At this point, you probably want to leave some of that stuff, since for 6 to the 4/3, that doesn't look like it's going to work out very nicely. But if it said find an estimate, you could put that in your calculator. If it says use an exact value, then you would not want to try to approximate it using decimal numbers.